All right, if you're writing Swift code, this is a decision you're making constantly, maybe without even giving it a second thought. But as we're about to see, the choice you make has some pretty huge consequences. Let's get into it.
So, you sit down, you're ready to build a new feature, and bam. First question, class, struct, or enum? It might feel like just, a minor detail, but does it actually matter which one you pick? Oh, you bet it does. It's not just about style points here. This one little choice, it actually dictates how safe your code is, how fast it runs, and maybe most importantly, how much of a headache it's going to be to maintain later on. The stakes are way higher than you'd think.
So let's really get into it. Choosing your type isn't just checking a box. It's really your first big architectural decision. And believe me, getting this right from the get-go is going to save you a world of pain down the line.
All right, first up on the block, the class. And the best way to wrap your head around a class is to think of it as a shared blueprint. Now that word shared is the key here, and you're about to see exactly why.
Okay, this slide nails the core difference perfectly. I love this analogy. Think about it like this. A class is like a shared Google Doc. I send you the link, you send it to someone else, we can all edit the exact same document in real time. But a struct, or an enum, that's more like me emailing you a Microsoft Word file. You get your own copy, you can change whatever you want, but you're only changing your version, not mine.
So let's put the official names on these ideas. That shared Google Doc, that's what we call a reference type. When you pass it around in your code, you're not sending the whole document. You're just sending a reference, a link, really, to that one single object in memory. And that personal word copy, that's a value type. Every time you pass it, you're passing a brand new, totally independent copy of all the data.
So the big takeaway for classes is that they are reference types. Because everyone's pointing to the same object, it means they have what we call a shared mutable state. Now this can be powerful, but it also means you have to be careful. This flexibility comes with some overhead. They're stored in a more complex part of memory called the heap, and they need these special deinitializer functions to clean up after themselves. And yeah, this is a big one. They're the only type out of the three that can do inheritance.
Okay, so that's the shared blueprint. Now let's talk about its total opposite, the struct, or what we're calling the independent copy.
Structs are pure value types. That means every time you pass a struct, you're creating a fresh, clean copy. This makes them incredibly safe, right? Especially when you're dealing with multi-threading, because there's absolutely zero risk of one part of your app accidentally messing with data that another part is trying to use. They're super lightweight, they're fast, and they usually live on a much simpler, faster part of memory called the stack. And unlike classes, no inheritance here.
And that brings us to our third type, the enum. Now, if a struct is kind of your general purpose, workhorse value type, the enum is more like a specialized tool. You can think of it as the ultimate state organizer.
Enums are absolutely perfect for what we call state modeling. Basically, anytime you have a situation with a limited, finite number of possibilities. Think about a traffic light. It can only be red, yellow, or green. That's it. A user is either logged in or logged out. There is no in between. And Enum lets you build that strict logic directly into your code, which is incredibly powerful for preventing bugs.
Here's a classic example you'll see everywhere, a network request. At any given moment, it can only be in one of these states. It's loading, it's succeeded and now has some data attached, or it's failed and has an error. You can't be loading and successful at the same time. And Enum models this reality perfectly and, more importantly, safely. And just like structs, enums are value types, so they get copied, not shared. But their real superpower is representing those distinct cases and letting you use powerful pattern matching with switch statements. Plus, like we just saw with the network request, those cases can have associated values, which means they can carry extra information, like the actual data from a successful request or the specific error from a failed one.
All right, so we've met all three contenders. Now let's put them side by side in a head-to-head comparison to really nail down the differences.
This table just cuts right to the chase, doesn't it? You can see the clear dividing line here. The class is kind of the odd one out. It's a reference type, lives on the more complex heap, and it's the only one that gets inheritance and deinitializers. Structs and enums, they're a team. They're both value types, they live on the simple stack, and they don't have those extra class-only features.
So, the big question, what does this all mean for you when you're writing code? Well, here's the game plan. You should use a class only when you explicitly need that shared state or inheritance. A great example from Apple's own frameworks is UView.
multiple parts of your app need to refer to the exact same visual element on the screen. For pretty much everything else, especially for modeling your data, like a user profile or settings, your default should be a struct. And anytime you're modeling a set of distinct states, an enum is your best friend.
And this really brings us to the single most important takeaway from this whole thing. If you only remember one thing from this explainer, please make it this. There is a swift way of thinking about this problem.
And here it is. This is the guiding principle of modern Swift development. Start with a value type, a struct, or an enum. Their safety and their performance benefits are just too good to ignore. You should only reach for a class when you have a clear, undeniable reason to, like needing that shared instance or inheritance. This value types first mindset is really at the core of writing safe, efficient Swift code.
So there you have it, the shared blueprint, the independent copy, and the expert state organizer. Now, the choice isn't just some random decision you make at the beginning, it's a powerful architectural tool. You know the difference now, so the only question left is, what are you going to build with it?